All right, we're going to be working on piecewise functions. And as much as we're doing all this other stuff with functions, I figure we might as well cover piecewise functions. It's not really as bad as the name sounds, but the name is kind of indicative because we are going to be dealing with pieces. Okay, so I guess let's get right to it. And the way I always like to kind of teach piecewise functions is to start off with an actual graph that is a piecewise, and we'll see if we can identify what it is. So we're going to actually be writing it from the graph. And remember, piecewise functions are functions that are made up of functions, at least two or more. Okay. And again, really important, you have to make sure that you only have one identified value for x. Remember what we said when we were talking about functions, it's got to be able to pass the vertical line test. And we'll talk about that as we go through. So first thing we want to do is we're going to identify our function is going to be f of x. So our f of x is going to be, now we have to identify what the actual function is. Well, we're going to first identify where our function is. So for this one, for the red piece over here, for this thing, okay, what we know is we know f of x or y is always equal to 4 for this entire function. So we can write that f of x is equal to 4. Now, it's only equal to 4 in this area, the area that we're in here, between here and here. So that's the important part. That's what we really have to identify. So that means that our function, our f of x, is going to be equal to 4, but it's only going to be equal to 4 when x is in between -4 and -1. Now, it cannot be -4, so that's why we're going to get a less than, and we can be -1, so we're going to get a less than or equal to. So now what that tells us is any value between, when x is any value between -4 and -1, including -1, your function is going to equal 4. So now we have to write the other part of the function. So we'll make this one a blue one. So we got to write this part. And remember, piecewise is just pieces. So in this case, our f of x is going to equal 2, right? Our y is equal to 2. So we know our f of x will equal 2. But when is it going to equal 2? Well, again, we know x is going to be between -1 and this value over here, which is +4. And it can't be -1, so it's got to be less than, not less than or equal to. But it can be +4, so it's going to be a less than or equal to there. Now, again, this is what we talked about before. This is really important. When you're looking at this, all right, you could see that I have -1 twice. I have a -1 here, and I have a -1 here. All right, but x is only allowed to be that -1 in this part because it's less than or equal to -1. In the second one here, it's not allowed to be -1. It starts at -1, but it can't include -1. So again, you guys remember when you did inequalities, you fill in the circle, you leave the circle open. Okay, that's kind of what we're doing here. Okay, let's take a look at another example. This time we're going to do it the other way. We'll start off with the equation and we'll graph it from the equation. For example, and this time we're given the equations and we have to graph it. So what we know is for our f of x is equal to 2x plus 1. So we want to graph that. I know it's only valid when x is less than -1, but I like to start off with the graph, and then what we'll do is we'll erase out the part we don't need, because I think a lot of you find it easy to graph it if you graph the whole line. So let's do that. So 2x plus 1, you guys remember how to graph this. So we go to +1, that's our y-intercept. Let me change colors, makes it a little darker here. Okay, and then we're going to go up 2 over 1, which would put us here, and we would go up 2 over 1, or you remember we could go down 2 and to the left 1. So down 2 to the left 1, and down 2 to the left 1 again, down 2 to the left 1. So you can kind of see what our graph looks like. Now, we would draw our line, right? Our line's going to go, and again, my tools aren't that great, so you have to kind of bear with me. That's as good as my line's going to get. But I'm really only concerned with the value when x over here, okay, when our x is less than -1. So that means I'm going to get an open circle where x is -1, and I'm going to keep everything that's less than that value. So let's erase. We don't need this part. Okay, but we do need the part when we get to -1. We need that part. So now I'm going to open circle that. Hopefully my open circle comes out again. So you can see I open circle that. And then this is the part of that graph that we're really concerned with, because this is all of those values when x is less than -1. So remember, x is less than -1. We're at -1. We want to go in this direction, right? Okay, so now let's graph the other one. Our other equation says that f of x is going to equal 1 when x is greater than or equal to -1. So when f of x is equal to 1, that's just this horizontal line here, right, at 1. Okay, you've seen that. But again, we're only concerned with when x is greater than or equal to -1. So for this one, we're going to erase this stuff until we can get to -1. But again, because this one has a less than or equal to, this time it's going to get a circle, but we're going to fill in that circle. Now, I know a lot of you are thinking, wait a minute, how can that be a function when I have if I put my vertical line on there, this doesn't work. If I put a vertical line, I go through here, I go through here. But you have to remember, in the first part, in the part of the equation that's 2x plus 1, you're not allowed to have -1 as a value. So this is sometimes called a jump. And it's a continuous function. It's not a continuous function, but it's got jump continuity. So this value, when you have this value here, that actually fills in the open circle that you have, like that circle down there. Okay, so that filling it in means that we now have a continuous value for every value of x. We're going to have a value for f of x. That's why it's still a function. Okay, let's try one more. Piecewise function has 3 pieces. And again, anything that has 2 or more pieces is a piecewise function. So in this case, we have 3 pieces. Again, start on the left and we'll go to the right. So our f of x, or y value, is going to equal 2 when x is less than -3. So that means when our f of x is equal to 2, that means we're going to have this line, right? But we only have that line when x is less than -3. So let's back this up. Let's get to -3. And remember, this means we're going to have an open circle, right? Because it's just less than, not less than or equal to. So here's our open circle. And we're shading to the left, everything to the left. Okay, the next part of our piecewise is going to be y is equal to, or f of x is equal to, x plus 1. So that tells us we know our slope is 1, and we start at 1. So we would go up 1 over 1, up 1 over 1, up 1 over 1. Then we go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. Okay, but this value is only valid for us between 1 and -3. So I only really need this part from 1 to -3. Okay, and if we look at it, the -3 side gets a filled in circle, and the 1 side gets an open circle. And let's get rid of these points because we don't need them. Okay, and then the last part of this is f of x, or y is equal to 1/2 x. And that's when x is greater than or equal to 1. So what would that function look like if y is equal to 1/2 x? Well, we know that that means we would start at 0, and we would go up 1 over 2, up 1 over 2, and then up 1 over 2. So our graph would look kind of like that. But we know we only need the value from 1. So this line that we would draw on here, right, we don't need that whole line. We only need it from when x is 1. So where x is 1, we're going to start. But remember, because it's greater than or equal to, that means we're going to have a filled in circle there. So we have a filled in circle there. And we erase anything that's less than that because we don't need that. And again, I'm sure yours is going to be much neater. Doing it on graph paper in a notebook, you'll have a ruler. But this is pretty much what that function looks like. And again, if you ran your vertical line test, which you're encouraged to do, right, you would see that on this vertical line, although it does hit twice, it's open the first time it hits up here, and then it's filled in over here. So we're good. On this one, again, you could see it's open and then filled in. So we're open here and we're filled in here. So we're good because we only have that filled in value, meaning x can only be -3 in one of those two values. So, and x can only be 1 in one of those two values. Again, really important to make sure that each value is defined only once because we want to make sure it stays as a function. Okay, and this is what piecewise functions are. And like I said, you could have a piecewise function with 7 pieces. You could have a piecewise function with 2 pieces. Sometimes you'll be given the graph and you'll be asked to write the function. Sometimes you'll be given the function